Hi and welcome. In this video, we are going to understand the problem statement for this particular problem in sorting section, that is find the window. Okay, I will explain you the problem and then just try out this question. Okay, just try first without watching the logic building and implementation videos. Fine. So let's see what the question says. We are given an array that is not completely sorted, but sorting a window in this array can make the whole array sorted. That window could be a complete array as well. So out of the several such parts, you have to find one with the minimum length. That is the question. Okay, fine. So given, let's say the test case 1, 3, 2, 7, 5, 6, 4, 8. So it says that the array is not sorted. But if you sort a window in this array, then the complete array becomes sorted. For example, if we sort from this index till this index, if we sort from this index till this index, okay, this window if we sort, then the complete array becomes sorted. If you sort this window, it will become 2, 3, 4, 5, 6, 7, and 1 and 8 were already present outside the window. So the complete array becomes sorted now. So the question asks you to find this particular window. Okay, in this question we need to find this particular window. Let's take another example. Now if we have 1, 2, 3, 5, 3, 4, 6, 8, 7, 10 and 9. Now in this, what is that window? So 1, 2, we can start with here and till the end. So if we sort all these elements, I think the array will become sorted. Therefore the answer is from 2 to 9. Okay, the index. We need to print the index of the window, the starting boundary and the end boundary of that window. Okay, by which if we sort the array, the complete array becomes sorted. Okay, if we sort the window, the complete array becomes sorted. So this is my constraint t, n equals to 10 to the power of 6 and ai equals to 10 to the power of 6. So t is 10 and n is less than equal to 10 to the power of 6, so it is nothing but 10 to the power of 7. So we can have an order of n solution accepted in 1 second. Okay, so we will find an order of n solution for this particular problem. So this was the problem statement understanding. What is the input, what you need to output, okay, what are the constraints, or what is the complexity that we need to solve this particular problem. Fine. So now just try it out on your own first. So this was problem statement understanding of find the window. So let's begin with the logic building. Okay, so if this is my sample test case that was given to us, that is 1, 3, 2, 7, 5, 6, 4, 8, and we need to find that which element, which index, which element is the reason that we do not have a sorted array. So this is not a sorted array, correct? We need to find the positions such that after sorting between those positions we get the answer, correct? So after 1 we get a 3, that's fine, because 1, 3, 5, 7 is also sorted, so that's fine. After 3 we get a 2, that is not fine, because now we know that here from this position we do not have a sorted array. We know that from this position we do not have a sorted array, correct? If we begin from the end now, 8, that's fine, 4, that's fine, because we can have 8, 4, 3, 3, 4, 8 is sorted, correct? 4, 6, this is not fine. Why it is not fine? Because if we are moving from a decreasing order, if we check from the end, that means we are moving in a decreasing order, correct? So 8, 4 and something less than 4 should have happened, but here we have something greater than 4, so that means here is the problem. So we find out that 3 is not at its position because an element less than 3 is coming after it, and 4 is not at its position because an element greater than 4 is coming before it, correct? So these two are not my positions, these two are causing the problem, okay? Now is this my answer? Is this my answer that if I sort from 3 to 4 all the elements in between, I get the correct output? In this particular case, yes, we get the correct output. If we can just find that which element is causing the problem from the beginning, and we can find that which element is causing the problem for the end, we can get the answer for this particular test case. Let's see the next test case, if we can get the answer for that also. So if we have 1, 2, 5, 3, 4, 6, 8, 7, 10 and 9, now here which element is causing the problem? So 1, it's fine, 2, that's fine, greater than the previous element, 5, yes, that's fine, greater than the previous element, 3, now it is not fine, it is not greater than the previous element. That means there is an element after 5 which is smaller than 5, which should not happen, okay? So here I will point out one thing. Now 9, after 9 we should get, before 9 we should get a smaller element than 9, but we are getting a larger element than 9. That means 9 is not at its correct position. So if we sort all the elements between these two positions, that is 0 1 2 and till last 9 index, can we get the correct answer? Let's see. 1 2, if I sort all this, we get 3 4 5 6 7 8 9. So yes, the complete array is sorted. So using these two examples, a logic comes to my mind, that if we can find the misplaced elements from the beginning and the misplaced element from the end, and if we sort all the elements between them, we get the correct answer. But is this logic correct? If we implement this, is this logic correct? Can we say that just by using just two test cases, only two given test cases, can we say this? No, we have to check this same logic that we have thought of for multiple test cases. Okay, so let's see more test cases, and if it can work on all of them, then we can implement it and see if it is correct or not. If not, we have to check for more test cases. Okay, so let's see that part now. Let's create our own test cases now. Okay, so let's test our logic for these particular problems now. Question test cases now. Okay, so this is correct, this is correct. Now here we have a mistake, because 7, after 7 we should have a greater number than 7, but we do not. So point at 7. Here it is correct, correct. It is not correct, because before 2 we should have a smaller number than 2, but we have a greater number. So point here. Now if I sort between them, it becomes 2 6 7 8 9. So this is correct. So for this our logic works. For 7 we should have a greater number than 7, but we have a smaller number. So point at the first index as well. Now 10 9 8 6, it is correct. After 6 we should have a smaller number than 6, but we have a greater number than 6. So point here. So if I sort these two elements, just 6 7 8 9 10, our logic works just fine. Now let's say for this 3 5 7, it's fine working. 6, no, it is not working right here, so point at 7. Now 10 9 2 8, no, it is not working, so point it here. So if I sort between this, we get 3 5 2 6 7 8 9 10. So is this sorted? No, this is not sorted. This here is not sorted. For this particular case, our logic is not working. Now let's check for this. So it is 1 5 3, no, it is not correct. 5 here point, and 7 3 3 8. So here point here. Now if I sort this, it becomes 1 3 3 8 3 7. This is also not sorted. So our logic does not work for some of the test cases that we have seen. Okay, so for those two our logic is not working. For some it will work, but for some it is not working. So now what we need to do? We need to think of something different, or do we need to modify it like this? Okay, yes, we will find these elements. They may be the correct answer, or they may not be the correct answer. Okay, if they are the correct answer, then we have to verify if they are or not correct. So we have to verify, we have to think of something else. Okay, now let's see of these two cases, what is the answer for these two and how we are differing, so that we can get the difference between our logics. Okay, so let's see with these two cases how the answer is differing. Okay, and then we can modify our current logic to match those answers as well. Fine, so let's do that. So let's see now for this particular test case what went wrong. So we know that this particular element is not at its correct position. We think that way, and this particular element is not at its correct position. Now if we sort it, it becomes 2 6 7 8. Okay, now the issue is there are elements that are greater than this element. There are elements that are present that are greater than this element, and they are outside the window. So we are not concerned about them till now. Correct? That was the particular issue in this particular case. Okay, the element that we are choosing inside the window, but there are elements that are greater than this particular element. Fine. So that was causing a major problem. Now because it will become 3 5 here. Now these elements are greater than 2. Okay, so that was causing the problem here. Correct? Now if we see in the second test case that we have just seen, 1 5 3 8 3 3 7. Now in this case, this particular one and this particular one is the case. Correct? If we sort, it becomes 3 3 8 3 3 3 5 8 3 3 5 8. Correct? Now if we see that we have the elements, we have some elements that are greater than this particular element after it. They are greater than this particular element after it. Okay, sorry, smaller than this particular element after it, but this element is the greatest one. It should be at the end. There should be no element greater than this element. Okay, so that was causing the problem. Here what was causing the problem is there are elements that are smaller, that are greater than this element. Okay, there are elements here which are smaller than this element. Okay, so we have to match these 2 points. We have to somehow match these 2 points, that when we select the candidates, to become a window boundaries, okay, are these candidates the correct candidates? Okay, or there are some other possibilities. Now in this particular case, okay, we need to sort from till the end, that is 1 5 3 8 3 3 7. So from here till the end, okay, not from here, because if we select this, there are still elements left. If we select this, there are still elements left, but till the end, if we sort till the end, we get the correct answer. And in this particular case, we need to sort from the beginning, because this 3 is actually greater than a element that is present inside the window. 3 is greater than the minimum element that is present inside the window. Okay, inside the window. And if you say is this 3 is smaller than an element that is present inside the window, okay, is 3 is smaller than the element that is present inside the window, correct? So what we got from this, we got that if we select boundaries, if we select 2 boundaries, let's say x and y, okay, so before x and after y also we need to consider few points. Before x and after y also we need to consider few points. What is the few point? The points are, in this window including x and y, okay, the minimum element present in this window, the minimum element present in this window should also be the minimum element in this part, okay, and the maximum element present in the window should also be the maximum element from this part, okay, from the right hand side. What is the meaning? So if I have 2 here and if I have 3 here, okay, so that means even if we sort it, the array will never become sorted. Okay, so if the minimum element present in this window was 2, and the minimum element present before this window was 3, that means our window starting point is wrong. We need to start with this minimum element. The minimum element here. Now if I sort this, 2 will come up before 3. Okay, similarly here, if I have the maximum element as 8 present inside the window, but the element here, the maximum element on the right hand side was just 7, so the maximum element on the right hand side is smaller than the maximum element present inside the window. Okay, that means even if I sort the window, this will not be affected and we will get an unsorted array, as we have already seen. Fine. So once we find x and y, which we can do using our logic, we need to find the minimum element present between x and y ranges including x and y, and the maximum element between them. Okay, now this minimum element we have to compare with the left hand side before x, and this maximum element we need to compare the right hand side after y. Okay, and according to that we need to change our x and y positions. Okay, now how we will change it? If we find an element which is greater than the minimum element here, we will point x to that element, and if we find an element which is less than the maximum here, then we will point y to that. Fine. I hope you understood these points. Okay, so now we are going to implement this particular code. Now in this one, what we just need to find x and y, initial x and y, that we can do. That is the first logic that we have discussed. After getting initial x and y, we can find min and max directly between this x and y, just running a loop. Okay, then we need to compare from 0 to x and y to n minus 1. Fine. In these elements we need to compare the min, and in this element we need to compare with our max and update x and y accordingly. Okay, because if we do not update x and y accordingly, we know that we will get a wrong answer. The reason being, a minimum element is present here, okay, and more than this element, an element is also present. So even if we sort 3 2, this will happen, not 2 3. This we need. Okay, but this will happen. We have to consider such more cases. Fine. So this was the logic building for this particular problem. Okay, in the next video we are going to see the first pseudocode for this particular case. What we will see in the pseudocode, what all the variables and all the elements and all the for loops that we need, and then we are going to implement after that part. Okay, So I hope you understood why we need to consider all these points, why just getting x and y are not correct. Okay, I have given you the cases for that part. Fine. So this was the video for the logic building. Thank you. So let's see the pseudocode first, and then we will see the implementation. Using the pseudocode, we will see what do we need. Okay, so take all inputs, that is fine. Now after taking all inputs, we need to find our start and end positions. Okay, the candidates of start and end positions, x and y. Okay, so let's take start and end as our positions, okay, as two variables. Now finding start and end is quite simple. We just need to check if my ai current element, if we are finding for start, we need to check if our current element is greater than our next element. If our current element is greater than our next element, then this current element will become our start index. Okay, and for end, when we come from end, so 9 8 7, correct, 9. Now in this position we need 7 as the answer. So that means if my current element, if you're starting from end, my current element is what, less than my previous element, my current element, that is I, is less than my previous element, then in that case this will become my end. Okay, so we have our start, we have our end. After having start and end, is this the answer we got? No, we have to check whether for the maximum and minimum part. So between start and end, including start and end, find the maximum and minimum. Okay, between these two ranges, find maximum and minimum. Okay, now for the minimum, compare from 0 to start. Okay, to start minus 1, sorry, from 0 to start. So from 0 to start, compare for minimum, and from our end to n minus 1, compare with maximum. Fine, and accordingly update our start and end. Okay, accordingly just get the actual indexes for which the window is correct. Okay, then print the indexes at the end. So this was the pseudocode. Okay, or the algorithm, whatever you like to say it, at end. Fine. Okay, so here we have a for loop, 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 here we have a for loop. So we have 5 different for loops in this particular code. Okay, elements we need start, end, max, min, and the last 2 indexes that we are going to store the final answer in. Fine, so this is the whole code. Fine, the pseudocode. Now let's see the implementation part for this particular example. Okay, so let's see the code implementation now. Okay, we are inside a test case loop. I have taken the array input and the n input. Now let's begin with the implementation. So take in start and end, in start and end. Okay, that will point to our windows starting and ending positions. Let's see, for start equal to 0, start less than n minus 1, start plus plus. Why start less than n minus 1? Because we need to check with our next element, correct? So we cannot go to the last element, we can only go till the second last element. So if array of start is what, greater than or less than? If array of start is greater than array of start minus 1, array of start minus plus 1. Okay, if start is greater than array of start plus 1, that is 5 2. So 5 is greater than 2, so that means we have to break our loops. We got our answer, we got our start position. Similarly, check for the end one. So for end equal to n minus 1, okay, and greater than 0, not equal to 0, greater than 0, same logic. Okay, we cannot go till the last element, n minus minus. In this case, if array of end is greater than or less than, so if array of end is less than array of n minus 1, okay, we are checking with the previous element. Okay, in that case we got the answer of end. Now once we got these 2 answers, what we need next? We need to find out what is the minimum and maximum values present between start and end, correct? So int minimum equals to integer dot max value and maximum equals to integer dot min value for the comparison part. Okay, now for int I equal to start, I less than equal to end, okay, including both start and end. If error of I or if maximum is less than array of I, we will update maximum equals to array of I. If minimum is greater than array of I, we will update minimum equals to array of I. Okay, fine. So we got our maximum and minimum. After getting our maximum and minimum, what we need next? So after getting this, we need to check minimum from 0 to start and maximum from end to end. Okay, from that means the end variable to the end of the array. Fine. So from int I equal to 0 to I less than start I plus plus. So here we need to check for the minimum. Say if array of I is greater than the minimum, that means we need to update our start. Okay, if we have 3 and minimum is 2, so that means we need to update the start to 3. That is what I'm doing. For int I equal to end I less than n I plus plus. So here we need to check for the maximum. So if AR of I is what, less than maximum or greater than maximum? It is less than maximum. That means we need to update our end equal to I. So we now get start and end both. So just print it out like this. Fine. So this is the whole code for this particular problem statement. Okay. After this, just let's run this for multiple test cases and see whether we have gotten it correct or not. Okay. So let's run for these test cases. So for the first one, 1 and 4 is the correct answer. For second, 0 and 1, we have seen that. For the third one, we start with 0, not with 2. Okay. And we got a 5. And for the fourth one, we start with 1, that is 5, and we end at 6, not at 3. Okay. So not between 5 and 8, but between 5 and 7 we will sort. So we are getting a correct answer. Okay. So this is the code for find the window problem. Okay. Thank you.